Alright, ladies and gentlemen, this is going to be our next video on cellular respiration. So let's get started on this next video. So let's go through the process of cellular respiration again. And cellular respiration is where organisms obtain energy from the food via the presence of oxygen by breaking the bonds in the food. Remember, this is occurring in the mitochondria. Now the chemical formula for this, remember, we're taking oxygen and we're taking glucose, C6H12O6, and then we're going through and converting it into CO2, H2O, and then that energy, that ATP. Now we can represent it in words again, oxygen plus glucose. Oxygen is O2, glucose is C6H12O6. And then we go through, convert it into carbon dioxide plus water plus our energy. So this is the overall process, and what we're going to do is zoom in depth and see how this functions. Now before we do that, we have to understand aerobic versus anaerobic environments and respiration. So aerobic pathways are pathways that require oxygen, whereas anaerobic pathways will not. So during an aerobic pathway, we have oxygen, and the first step of respiration is going to be glycolysis. We're going to break apart our glucose molecule. Now, assuming that oxygen is present, we'll go down to the Krebs cycle, and then from the Krebs cycle, we'll go down to the electron transport chain. Now, anaerobic pathways are pathways that do not require oxygen, and they're considered anaerobic. So if oxygen is not present, well, organisms are still going to go through glycolysis in the cytoplasm. However, the difference here is if there is no oxygen, no O2, well, now what is going to happen is what we call fermentation, either alcoholic fermentation or lactic acid fermentation. And this is the reason that when you work out really extensively, why you get that burning sensation in your muscles and cramps. So what we're going to do is delve into both of these in a little more detail, but in this video, we just want to look at the basics before we zoom in on both of those. Now remember, this process is a three-step process. We start with glycolysis, we then go to the Krebs cycle, and then we go to our electron transport chain. So as we're going through and looking at this, let's delve into glycolysis. Now glycolysis is going to take glucose, and each one of these gray spheres represents a glucose here, and it's going to break it apart into two pyruvates. And these are the new pyruvate molecules because they each contain 3 carbons. Now when we go through and break this, we're going to get energy, we're going to get 2 ATP, and then we're going to feed these pyruvates down to the Krebs cycle. So now we're within the mitochondria here. Glycolysis is that first step. We take the pyruvate and we send it to our Krebs cycle. Now in the Krebs cycle, we're also going to release energy. We're going to get 2 more ATP out of there. And in the process of glycolysis and the Krebs cycle, we're releasing that carbon dioxide. Now, once we get our ATP, our NADH, and our FADH2 from the Krebs cycle, we're going to feed it into the electron transport chain. The electron transport chain is going to take the oxygen electrons, we're going to go through, convert it into water, and this is where a vast majority of the energy is made. This is where 38 ATP are made. So what we're trying to do is get glycolysis in the Krebs cycle to make electron carriers, make a little bit of ATP in the meantime, but make those electron carriers to feed into our electron transport chain, that FADH2 and that NADH, to power that ATP synthase and make the energy, the ATP that we need in our bodies. So if we go back to this original animation, remember we're going from sunlight, we're going into the chloroplast, we're making that glucose, and this is where we start cellular respiration. Glucose goes through and gets fed into the mitochondria to make that ATP. So we went from light energy to chemical energy stored in the glucose to chemical energy released in that ATP. But so far we've looked at photosynthesis, that's everything on the left, and now what we're looking at is everything on the right. So let's go through and look at oxygen and energy. Oxygen is required at the end of cellular respiration, and this is what we refer to as breathing. And pathways that required oxygen are going to be aerobic. So aerobic, remember, it requires that oxygen. The Krebs cycle and the electron transport chain both require that oxygen. Now, pathways that don't require oxygen are considered anaerobic, so no oxygen is necessary. Now, the first part, glycolysis, that is not going to require oxygen. And also fermentation, either lactic acid or alcoholic fermentation, does not require oxygen. So when we're referring to aerobic parts, we're referring to the Krebs cycle and electron transport chain. And we're referring to anaerobic, we have glycolysis and fermentation. So if we're comparing photosynthesis and cellular respiration, let's go through and look at a plant and animal here. Now, in this image, we're going to have sunlight, which is the energy, the light energy that's going to power photosynthesis. And photosynthesis is going to go through and make glucose, C6H12O6, and 6O2. So we're making oxygen and we're making glucose. Now this is going to go, and this rabbit here is going to go through and consume that. And the rabbit's going to go through cellular respiration. Now cellular respiration is going to generate ATP and energy. And then that energy is going to power that rabbit. Now the rabbit's going to release H2O and CO2. And the plant's going to go through and absorb all of that H2O and CO2, and the cycle continues. We call this cyclic because it's a circle. And the plant requires the H2O and CO2, whereas the animal requires the glucose and the oxygen. And both of them feed each other to make this process work. So it's a perfect process and perfect harmony between animals and plants. So what we have here is a concept map. And this concept map should help you kind of put together these ideas. Now, if oxygen is present, aerobic respiration here, well, a few things are going to happen. We're going to go through glycolysis, but then in the presence of oxygen, we're going to go through the Krebs cycle, and then we're also going to go through the electron transport chain. Now, the whole goal of this is to generate as much ATP as possible. Now, if oxygen is not present, well, then we have no oxygen, it's anaerobic. What's going to end up happening is we go into fermentation. So we'll go through glycolysis first, because glycolysis doesn't really require oxygen, but then we're either going to go into lactic acid fermentation, or we're also going to go into alcoholic fermentation. Now, the whole goal of cellular respiration is to produce energy. We're making ATP in this process. So if we think about the formula here, we're taking that oxygen, we're taking that glucose, what we're doing is we're generating carbon dioxide and water as byproducts, but the ultimate goal is to make that energy. So if we're looking at photosynthesis and cellular respiration, well, the plant's going to go through and it's going to remove carbon dioxide from the atmosphere. It's going to take in that carbon dioxide, it's also going to take in water, and then it's going to go through and release the oxygen into the atmosphere. Now, organisms are going to go through cellular respiration because they use oxygen and they release the energy from the food via this oxygen. And the organisms are going to put carbon dioxide back into the atmosphere as they go through cellular respiration, and the cycle goes through and continues. Both the plants and the animals depend upon each other in this cycle in order for photosynthesis and cellular respiration to occur. So, did you guys learn? Well, did you learn a couple of things? Did you guys learn what cellular respiration is, the overview? Did you guys learn about anaerobic versus aerobic respiration? And then did you guys learn about the parts of cellular respiration, the overview and the basics, and how it relates to photosynthesis? This is going to be the end of the video. I will see you guys in class tomorrow.